Welcome back, continuing to talk about linear relations and functions. When we have a linear relation in the form ax plus by equals c, the best way to go about graphing these is to use x and y intercepts. The x-intercept is where our graph crosses the x-axis. It's where y is equal to 0. We can write these ordered pairs as x comma 0. So it's some value of x that goes along with a y value of 0. And our y-intercept is when x is equal to 0, so these are often written as 0, y. You want to write the x and y-intercepts as ordered pairs, but they have these qualities about them. The reason I like to use this information when graphing from standard form is when we get into graphing from our other forms, you'll see that we've got specific things we can pull out, but I don't have a ton here. What I can do is find my x and y intercepts. To do that, I've got my linear relationship here. 2x minus 3y is equal to 12. So I want to find the value of y that will make a true statement when x is equal to 0, and the value of x that will make a true statement when y is equal to 0. I use what's called the cover-up method to do this. So if x is equal to 0, this whole first term disappears. So if that first term disappears, I end up with, so this is if x is equal to 0, I end up solving the equation negative 3y is equal to 12, divide both sides by negative 3, and I get y is equal to negative 4. So I have the ordered pair 0, negative 4. What that means is that if x is equal to 0 and y is equal to negative 4, and I plug both of those values into this equation, I will have a true statement. So if I graph that, x value of 0, y value of negative 4, 1, 2, 3, 4, that's going to graph right there. 0, negative 4. If I plug in a y value of 0, this term is going to disappear. So I can cover that up with my finger, and so y is equal to 0. I'm now solving the equation 2x is equal to 12. Divide both sides by 2, and I get x is equal to 6. So this means if I plug in a value of 6 for x and 0 for y, I will have a true statement. So 1, 2, 3, 4, 5, 6 is right here. So this is 6, 0. I can now go through, now that I have 2 points on a line, we learned from geometry that any 2 points define a line, and I can draw the straight line through those 2 points. What this graph represents is every set of ordered pairs that will make a true statement. So every ordered pair that I could pick off of this graph will make a true statement, which is a really important key thing for us to understand when we're working with this. When we're working with any of our equations, is that when we graph them, we are representing all of the values, all of the ordered pairs that will make this statement true.